Hey guys, in this video we're going to take a look at really good proof for the angle sum formula for trigonometric functions. In particular, we're going to do it for the cosine one. And the angle sum formula says that cosine of a plus b should be equal to cosine of a cosine of b minus sine of a sine of b. So we're going to take a look and see if that's true. The most common proof out there on the internet seems to only work for when a plus b is an acute angle and neither of them are negative. So I like this one because it actually works for any values of a and b that you want. And so yeah, we're going to take a look at that today. Hope you enjoy it. Okay, first of all, let's note that this is angle A, and because this is angle A is in radians by the way, so this is angle A. This point here, by the definition of the cosine and sine functions, if we make a little right angle triangle there, then we must have this red point up on top is equal to cosine of A for the x coordinate, because this length is cosine of A, and the y coordinate must be sine of A, because this length here is sine of A. Alright, so that's all that's going on there. For similar reasons, because of the definition of these functions, we must have that this green angle is equal to b, because the green point is cosine of a plus b and for the x-coordinate and sine of a plus b for the y-coordinate, so the entire angle must be a plus b. And finally, this angle here is negative b, because this is the point cosine of negative b, sine of negative b. Alright, now go look at the radians video if you haven't already, or if you don't know why this is true. But because we have angle A here in radians, it must be the case that, well, since this is a unit length circle, it has a radius of 1. Because this is a unit circle, this distance here, this red distance around the outside of the circle, must also be A units, whatever the units are. So that distance, from the pink point to the red point must be A units. And similarly, this distance here, this green distance, must be B units. Down here, this distance must be negative B. Well, no, negative B doesn't make sense as a distance. You can't have a negative distance. The only reason it's negative is because we're going that way around the circle instead of, we're going clockwise around the circle instead of anti-clockwise. So this distance here is still B as well. And more importantly, we observe that the distance from this point to this point is the same as the distance from this point to this point. They're both equal to A plus B units when we're going around the edge of the circle. And that's very important because it means that when we draw two lines, when we draw two straight lines like this, so I'm going to draw one straight line from the green point to the pink point, and I'm going to draw another straight line. Sorry if it's not actually straight, if it's a little wonky, but you get the idea. It's supposed to be straight. I'm going to draw another straight line from the red point. That was horrible. Let me give that another go. From the red point to the blue point. That one's even worse, but I'm done drawing straight lines. They're straight lines, okay? And in particular, because this distance from here to here and this distance from here to here are the same, it must be the case that these two straight lines have the same distance as well. And in fact, we can use, Pythagoras or coordinate geometry or whatever you want to call it, we can actually use the distance formula to calculate the length of these lines. So I'm going to call this one line 1, and I'm going to call this one line 2, and I've written the distances down. So remember, the x-coordinates of line 1, the first x-coordinate is cosine of A plus B. The second x-coordinate is 1. So I'm going to have square root of cosine of A plus B minus 1, and then that thing squared, plus the first y-coordinate minus the second y-coordinate. So it's just going to be plus sine of A plus B squared minus 0. Sine of A plus B minus 0 squared, which is just sine of A plus B squared. I know I said a lot there, but you'll see what I mean in a second. So let's go to the formulas. So these are the distances of our two lines. Again, first x-coordinate minus the second x-coordinate squared, plus first y-coordinate minus the second y-coordinate, which was 0 squared. So that's the distance of line 1, and the distance of line 2 we compute similarly. Distance of line 2 is computed by taking the first x-coordinate minus the second x-coordinate squared plus the first y-coordinate minus the second y-coordinate squared, and then we take the square root of that. So that's where I got the second formula from. And now, well, both of these lines, as we said, line 1 and line 2, both have equal distance because of what we just worked out before. So it must be the case that, in fact, these two lines are actually the same distance, and therefore this thing must be equal to this thing. And because they're both equal and they're both distances, so they're both positive, we can actually just square both sides and get rid of these square root signs. So we got cosine of a plus b minus 1 squared plus sine of a plus b squared is equal to cosine of a minus cosine of negative b squared plus sine of a minus sine of negative b squared. All right, let's expand both these things out. Expanding the first one out, so expanding this guy right here out, we get cosine of a plus b squared, so cosine of a plus b squared, the little 2 goes here for some reason, and then minus 2 times this one, so minus 2 times 1 times cosine of a plus b, so minus 2 times cosine of a plus b, plus, plus negative 1 squared. Negative 1 squared is still 1, so it's just going to be plus 1. So that's this one expanded out. And now we're going to expand the second one out. Well, there's not much to do there. It's actually just sine of a plus b squared plus sine of a plus b squared. And that's what that says. Well, something special now. We observe that cosine of a plus b squared plus sine of a plus b squared is actually also just equal to 1, because cosine of any angle squared plus sine of that same angle squared is always equal to 1 by Pythagoras' theorem. Draw some triangles if you're not sure why that's the case. And draw the triangles on a graph with the point 0, 0 being one in the corners. All right, anyway, so what we actually have on this side, this is 1 plus 1 makes 2. So it's going to be 2 minus 2 times cosine of a plus b. So that's the first side done. That's this one right here. The second one, we're going to expand in the same way. So cosine of a minus cosine of b squared, that's going to be equal to cosine of a squared minus 2 times cosine of negative b times cosine of a. Well, cosine of negative b, actually, because cosine's graph is symmetric about the y-axis, doesn't matter whether you put a negative or a positive number in there, it's going to be the same as long as the absolute value of those numbers are the same. So cosine of negative b is actually equal to cosine of b. So when we expand this thing out, it's the same as cosine squared of a cosine of a squared minus 2 times cosine of a times cosine of b plus cosine of b squared. Again, the two negatives cancel it out. So plus cosine of b squared, and that's this one expanded out. Pretty much the same thing for the second one, for this one right here. So plus, let's expand that one, sine of a squared minus, well, actually no, in this case it's a little different. Sine of negative b, sine is not symmetric about the y-axis. It actually, if you put in the negative version of a number, it actually makes the graph negative. It actually gives you the negative value out. So sine of negative b is actually equal to negative sine of b. So it's going to be, so this one right here in the red box is actually negative sine of b. So this set of brackets here might as well actually be sine of a plus sine of b, because those two negatives will cancel each other out. So what we're really expanding here is sine of a plus sine of b squared. So when we expand that, we get sine of a squared plus 2 times sine of of b plus sine of b squared rather. We are nearly done, because now we observe this magical thing from Pythagoras' theorem again. Cosine squared of a plus sine squared of a is just equal to 1. And cosine of b squared plus sine of b squared is also equal to 1. I don't know why I keep calling them cosine squared of b and sine squared of b. I think it's just because I'm used to writing it like that, so I've been saying it wrong in my head for too many years. Anyway, enough about that. So what we end up with here on this side is actually equal to 2. So 1 plus 1 equals 2 minus 2 cosine of a cosine of b. Plus 2 sine of a sine of b. So that's that part, plus 2 sine of a sine of b. 2 sine a sine b. Running out of room. Okay, I'm going to go to the new board and collect what we have. So remember, on this side we got 2 minus 2 cosine of a plus b, and on this side we got this thing. So let's go to a new board. So what we have is 2 minus 2 times cosine of a plus b, and we just worked out that this is equal to 2 plus 2 sine of a times sine of b minus 2 times cosine of a times cosine of b. And then the rest just falls out from algebra, because this 2 cancels with this 2, just subtract 2 from both sides. And now we're going to divide both sides by -2. So this cancels, and this 2 cancels and becomes a negative, and this cancels and becomes a positive. And what we end up with is therefore cosine of a plus b is equal to cosine of a cosine of b minus sine a sine b. Exactly as we were supposed to. And now, to get the sine version of this formula, you can use the fact that sine of pi over 2 minus x is equal to cosine of x. And conversely, cosine of pi over 2 minus x is equal to sine of x. So you can use these formulas. Cosine of pi over 2 minus x is equal to sine of x. So you can use these two formulas to get the sine version, and make sure it still works using the diagram. Make sure we haven't done any specific cases that the diagram doesn't include, because the whole point of this is to prove it for all values of a and b. Okay, that's it. Thanks very much for watching. Hope you enjoyed it. See you guys next time. Take care. Bye.